Everyone, welcome to this week's edition of Spatial Spotlights with me, Helen McKenzie. Today we are going to be looking at creating a wildfire risk index with CARTO and Snowflake. This is basically a spatial score which establishes which parts of areas like Los Angeles, where we'll be focusing on today, are more at risk of wildfires due to all sorts of different variables. We're going to be taking an approach which is very scalable, so looks at a very large area, but is also very hyperlocal, so you can zoom in and really get those hyperlocal insights. So I'm going to share my screen and we're going to get started. So just for your reference, if you would like to follow along with anything I'm doing, maybe recreate this analysis, you absolutely can. If you head to carto.com, you can sign up for a free 2-week trial. And then all of the data that I am using today is essentially either available via the CARTO Spatial Data Catalog or is open data, so you can find it and access it yourself. So what you're looking at here is CARTO Workflows, which is the tool that we're going to be using today to create our Wildfire Risk Index. Workflows is, as you can hopefully see, a visual interface, a drag and drop solution for building complex spatial analysis, kind of flowchart style. So you drag items on and you connect them, and it's really, really simple and intuitive. So I've already started to build some of the workflow for this, and we're going to build on this today. So there's 4 main factors that we're going to use to develop our wildfire risk index. First of all, we're going to be looking at some climate factors, and the data set we're using for this is this one here. Let's just preview it, which is CARTO's spatial features dataset, which is essentially a global grid system which contains all sorts of information on demographics, the economy, the environment, climate, and it's climate that we're really interested in today. So the particular variables we're interested in for this are these ones here. So the temperature max variables. This one kind of is goes without saying, the higher the temperature, the more likely fires are to start and be sustained. And then we're also interested in wind variables. So average wind, the greater the wind, the more likely fires are to spread, essentially. So I've already done a bit of work with this data to just get it into the format that we're after. So what I've just done here, just for the record, is this data set you can see, hopefully you can see, has about 12,700,000 records in it. It's absolutely huge, and it covers all of the United States. So the first thing I wanted to do was just drill this data down to Los Angeles, just our area of interest. So the way that I did that is I took this table here, which is USA counties data. I filtered that here using a simple filter just to the Los Angeles area. And then I did something called a H3 polyfill, which essentially creates a H3 spatial index, a hexagonal grid across our area of interest. You can see here, Los Angeles County. And the thing about H3s that make them really, really useful for this kind of analysis is the H3 cells are georeferenced with this really short reference string. I think it's 14 characters long. And that means that when we're doing the kinds of spatial analysis like spatial joins and spatial filters and things like that, we can actually sort of remove geometries from the equation, geometries being really massive, really heavy to store, really slow to analyze, and basically do kind of like for like string joins. And that makes this analysis so much quicker. And that's exactly what I did. So I used a join here to basically join, using a left join all of the spatial feature cells which contain that climate data to the H3 cells which cover Los Angeles. And by using a left join, I essentially did a spatial filter, but because we're using H3 cells, we can replace that need for geometries with strings, making this super fast. Then these 2 components here, really, really simple. I just wanted to get a aggregated value for the entire year. So I wanted the maximum temperature in this column and also the average wind speed. And then finally, you probably noticed right at the start of this, when I showed you the spatial features dataset, that it's got loads and loads of columns in it, which makes it absolutely massive and a bit unwieldy. So I just did a select here to just select our 3 columns that we're interested in from that table. So the H3 cell, the maximum temperature, and the average wind speed. So those that's where we're up to now. Now it's for us to build on this. So now we have two elements of our wildfire risk index. We have temperature and we have wind speed. So the next element that we want to add into this is burn propensity. So let's just preview this so you can see what I'm talking about. I'll open this up. So this is a H3 layer natively, so we don't have to worry about any sort of converting this from geometries. But you can see we have this burn pop column, which is the propensity of areas to basically burn depending on their land cover. So where values are closer to, for instance, 1, that is where areas are more like have a higher propensity to burn. Maybe there's lots of trees in the area, maybe there's lots of crops or shrubland. When the value is closer to 0, that means there's a lot more maybe water in the area, or maybe bare earth, or just sort of land cover that doesn't tend to burn as much. So all we need to do here is we just want to join this to our other table, so we get everything into one nice, neat table. So we'll use a join component here and just join the two. And again, by using H3 spatial indexes, this just makes this type of analysis so much smoother, depending on how good your Wi-Fi is. Mine is not. So we'll just run that. And again, by using that left join, we're essentially doing a spatial filter here without having to do a spatial filter. And you can see how quick that was. That was literally a matter of seconds. What's really handy about CARTO workflows is components will turn green if something has worked correctly. They will turn red if they haven't worked correctly. I'm sure I'll be able to demonstrate for you that for you at some point soon. And they will also show the number of output features, so you can check and sort of troubleshoot that analysis has worked how you'd expect it to. So we now have our 3 of our 4 variables in here. So we have temperature max, average wind, burn pop joined. What I'm just going to do is add a drop column, to get rid of this H3 joined, just so I can keep our table nice and neat and nice and small as well. So we'll drop column, H3 joined. Run that. Great. So the final piece of the puzzle for our wildfire risk index that we're going to add in today is historic wildfires. So obviously if wildfires have happened in an area in the past, there's a chance they could happen there again. We're already seeing sort of ideal conditions for wildfires. So we have this data set here, which is again open data. Let's just preview it on the map so you can see what we're working with. Let's just open that. So, oh, my Wi-Fi really is bad today. There should be a base map on here. So what we're working with here is essentially historic wildfire perimeters. The way that we're going to attach this to our grid where we're collecting all of our variables is we're going to first turn it into a H3 layer using a H3 polyfill component here. And the way that H3 polyfill works is it will essentially create a H3 cell for the extent of the polygon per polygon. So where you have overlapping polygons, you will have overlapping duplicate H3 cells. So let's go ahead and add a group by component to here. And we want to group by the H3 cell. And then we also want to do a H3, not shape length. A H3 count. And this will count the number of essentially overlapping H3 cells, and that's essentially the number of overlapping wildfires. So we'll just run that. And then we're going to join this to our drop columns up here, to our wider grid. So that's run. Let's just get the join ready while that finalizes. So let's just take a look at the results of the group by. Open this up, data, H3 count. So you can see we have the number of wildfires in each of these H3 cells. So let's just join these together. H3, H3, and we want a left join, because the final thing that we need to do here is, because this H3 polyfill has only created cells which cover areas with wildfires. We've got null values now for all the areas which don't have a wildfire. We essentially want those null values to become 0 values. So what we're just going to do in here is add a case when component. And we want to say when H3 count joined, which is our count of wildfires essentially, when that is greater than or equal to 1, then we can keep the value as H3 count joined. So I can just add this into here. But when there's no value, when the value is less than 1, then we want it to be 0. And then we just want to call this fire count. So we'll hit run on that again. And this now we have our 4 variables: temperature, wind, burn propensity, historic wildfires. We'll now have this in one grid. What we just need to do so we can combine them into one sort of score is we need to make it so we can compare all of them. And what that means is we need to have each of them translated from their raw values into a value out of 1. Now our burn propensity is pre-normalized because it's a pre-normalized score from 0 to 1. We just need to add in a couple of normalized components to be able to do that. So let's add in a normalize and normalize temperature max. Run that. And what this is essentially doing is recalculating the values and saying where the value is higher. So when the hottest place in Los Angeles will be given a score of 1, and the coldest place in Los Angeles will be given a score of 0. And then we'll just repeat that for the other 2 variables. So now let's repeat this for wind. Wind average run. And then we'll want one final variable to do this with, which is the fires count. And with workflows, you've probably picked this up as I've been doing this, but you can either basically build the whole workflow and run it right at the end, or build it bit by bit and run it bit by bit, or whatever you choose to do. You can delete connections and just run a certain section. It really is up to you depending on how you like to work. Personally, I like to sort of run it bit by bit and just check things are working how I expect rather than have any surprises at the end. What's also great about workflows is once you have run something, that analysis is stored in the cache. So every time I'm clicking run here, it's not rerunning the entire workflows. It's only rerunning the bits which I've added or edited. So we have our 3 normalized variables in here now, and we're just going to combine them into one score. We're going to do this in quite like a simple and kind of crude way. There's lots of different ways you can maybe bring these together in a more sophisticated way. So if you saw the last of our spatial spotlights, my colleague Miguel did a session all on composite scoring, which is a great way of bringing together lots of different variables. But in this case, we're just going to go for something quick and simple because there's nothing wrong with quick and simple. So we're just going to add these 4 scores together. So this is where I always do lots of typos and always forget the names of variables. So please bear with me. It's been a long day. So we want burn pop joined plus temp max norm plus wind average norm. And then the final one, which is, just move along here, fires count norm. And we'll add all of those together. So let's just run that. And while that's running, let's just zoom out to take a look at the whole workflow that we've built in the last sort of 10-15 minutes. We started here. So we've built all of this stuff. We've analyzed 15,000 features multiple times across multiple components. And we've got to this score incredibly quickly. So you can see this is finished running. It's ready to view. So let's just open up the preview. Apologies, I'm based in the UK and we're having a massive storm here, and I think the Wi-Fi is just really on its last legs. So if we go into the map preview, we can hit Create Map. This will open up a new instance of CARTO Builder and load your component, load the results of your analysis into CARTO Builder. You can do this with any component in workflows, and what workflows will do is save your analysis for 30 days as a temporary file. Which is really handy if you want to sort of iterate and try lots of different things. And then you can also use a save as table component in workflows to commit any results as permanent tables. So here is our result. Let's just quickly see what it's looking like. So I'm just going to increase the resolution so we can see it's nice and detailed. Let's remove the stroke and then let's color our cells based on score. And let's choose a nice orange and red color scheme as is appropriate for the theme. Change this to quantile. Great. And we can see, here's the results of our analysis. So we can see, let's just change this base map to something where we can see the labels on top to give us a bit more context. So the darker, pinker areas are areas where we think there's a higher risk of wildfires, and the yellower areas where we think there's a lower risk of wildfires. So, for example, we can see down here in the area around Malibu, very dark pink areas. We know that Malibu actually has a lot of historic wildfires. I think in 2018, there was a very, very serious one. We can also see areas more towards the north of the county where there's maybe a lot more rural land, more woodland, more shrubland, etc. There's greater risk up there as well. Whereas towards Los Angeles, the sort of more urban hub of the county, where there's less shrubland, but also is slightly more sheltered from the winds potentially, there's a lower risk. So that is a real whistle-stop tour of building a wildfire risk index. The next steps from this would be to sort of bring in maybe some demographic data, maybe align this with infrastructure data like housing or any sort of infrastructure to work out what infrastructure is most at risk from wildfires. But essentially, yeah, that's a really quick whistle-stop tour of how to build a wildfire risk index. I hope you found it useful. We do these spatial spotlight sessions every 2 weeks here on LinkedIn. I believe the next session is my colleague Anna talking all about how you can build maps like this, but then sort of add in parameters into the URL so you can control the map to create lots of different versions for your users. So if that sounds interesting, I really do recommend you come along to that one. Otherwise, thank you so much for listening and have a great rest of your day.